Hello everyone and welcome back to our channel Quaint. Today we are going to explore a fascinating concept that could redefine the way our world communicates. It's a technology that makes eavesdropping physically impossible. Yes, we are talking about QKD, that is quantum key distribution. Okay, so you can see there is a word key. So what is the meaning of key in digital communication? In digital communication, a key is a secure code that is used to encrypt and decrypt information. And if this key is stolen, then in that case your data becomes exposed. And in most of the cases, hacking happens today this way. They steal that encryption key. Means the hackers steal encryption key. Anyway, so we are talking about what? QKD. This is a new technology. Actually, already few countries are there like China, then the USA, Japan, few European nations, they have already demonstrated this thing successfully. If I talk about China's Micius satellite, so they have actually used ground stations which were actually thousands of kilometers apart, and they have successfully, and this happened actually in the year 2017, 8 years ago. This is 2025. Anyway, so they have already successfully, China's Micius satellite has already demonstrated this thing successfully. Okay, so we are talking about what a QKD. Here, you know, in case of present-day computers or present-day internet or present-day communication systems, normally human-made algorithms are used to encrypt keys. Okay, human-made algorithms, but here in case of QKD, the communication system becomes unhackable because what? Because of laws of nature, or more specifically, laws of physics. Which law? You know, Heisenberg's Uncertainty Principle is there in quantum mechanics. Actually, that law is used. Means scientists actually take advantage of that law to protect your data, to develop that technology, QKD, quantum key distribution. Okay, this is the reason. Because we cannot break that law, we cannot violate that law, we cannot go against that law. Which law? Heisenberg's Uncertainty Principle. So what is done actually here in QKD, QKD actually uses fundamental or the quantum particles, better to say quantum particles. QKD uses quantum particles, usually photons. Okay, for what? What is the purpose? For the distribution of what? Distribution of encryption keys between two users. Often they are called Alice and Bob. And when, for example, you just assume that Alice is sending a stream of photons to Bob. So the question is, why photons are being used? Because photons are what? Quantum particles. They have one property called polarizations. Those are what? Quantum states. And those quantum states can be linked, quantum means quantum entanglement is possible in that case. Anyway, we are not talking about those things here. Here we are talking about only QKD. So, say for example, Alice is sending a stream of photons to Bob. And here, each photon carries a piece of that encryption key. A tiny piece of encryption key, better to say a tiny piece of encryption key. And when this thing happens, simultaneously one more thing happens that is most amazing. What is that amazing thing? That amazing thing is, if someone now, when Alice is sending that photon particles, a stream of photons to Bob, and if someone, say for example, if tries to intercept that photons, something amazing happens. Due to what? Due to that rule of quantum mechanics, Heisenberg's Uncertainty Principle. Means whenever someone here, for example, Eve is trying to intercept those photons. So what would happen in that case? What will happen in that case? There will be a change in quantum states, because whenever you are trying to intercept, that means you are trying to measure the quantum state, immediately what happens? Immediately there will be a change in the quantum states. Okay, without disturbing the system or without disturbing the quantum particles, you cannot measure them. And when this thing happens, means when Eve is trying to intercept that photons, shows something magical happens. What is that magical thing? Change in quantum states, and that is immediately noticed by both Alice and Bob. Means they notice what? They notice that in their system, communication system, or in their encryption keys, some discrepancies have already occurred. Okay, that's why we are saying that, means scientists are saying that it is physically impossible to intercept those photons without being detected, since there is a change in quantum states. Whenever interception occurs or an attempt is made to intercept those photons, okay, in that case this thing happens. Change in quantum state happens, and that becomes noticeable by both the users. Here in this case, Alice and Bob. So what is actually done? A portion of the key is actually compared by both Alice and Bob. What is the purpose? Why they check? To check whether there is any tampering or not. And after that, they actually use the remaining portion as the encryption key. But in this case, you just keep in your mind that QKD does not send messages. QKD is not used to send messages. Just the encryption key is established by the use of QKD technology. Encryption key is established, and after that actually classical computing methods is used to send data. And I have already mentioned that already few countries have demonstrated this thing. They are actually building quantum networks across the globe this way. But challenges are there, because loss of data or loss of signal is there while they are passing through that optical fibers, and cost of quantum hardware is too much, very expensive. So building quantum networks across the globe is quite challenging, but countries are doing the same thing. Actually, this technology is unstoppable. Progress is rapid, and we can easily say we can easily say that in future the quantum internet will be built upon this technology, that is QKD. Purpose is secured communication. Purpose is to detect any attempts of hacking instantly. Yes, detection becomes actually instantaneous this way by using this QKD technology. Anyway, so this was all about today's topic, QKD, quantum key distribution. Okay, this technology is not used to send messages or encrypt messages. Classical methods are used to encrypt messages. Okay, actually this is used as an encryption key. Anyway, so this was all about today's topic, and this is the end of this video. If you found this video fascinating, so please like, share and subscribe to our channel. This is the end. Thanks for watching.